Hey everybody, welcome to the webinar today. As you can see, we will be covering word problems. I'm actually pretty excited because I'm going to teach one of my favorite topics, which is actually inequalities with word problems. So there's a lot of cool stuff I'll be doing, and of course Scott, I'm sure, will be challenging the heck out of everyone as he gets going. Before we start, I wanted to mention another great success we had about a week and a half ago with one of our students. She was taking the GMAT for the first time. You know, she was able to raise her score, I believe, about 90 to 100 points into the mid-700s. And she, like most of you here, are following our curriculum. And, you know, she did exactly what she needed to do. She basically started at the way beginning. She followed the study plan. She went through each individual topic, did her chapter tests, and most of all, she used patience and determination, you know, getting through everything. So for those of you who are in the midst of their GMAT prep, using our materials, you know, just trust in the process. You know, Scott and I have been doing this for a lot of years. We love the curriculum that you're all using, and we know it can work, but you have to make sure you trust in the process and that you follow things methodically, and most of all, you never give up. And, you know, if you want, you can totally read about, you know, what she did. She wrote on Beat the GMAT, and there's a lot of really cool stuff that you could learn from it. She provides a little bit of advice in there, but, you know, we know there's going to be a lot more students breaking into the 700s in the months to come, so we're really looking forward to hearing from all of you as you do that. Of course, during your journey, you always know you can reach out to Scott and I for help. We're always here to answer questions and be at your service. So with that said, we are going to practice some GMAT questions. Now, as I said, I am excited to do a lot with inequalities and how they relate to word problems. But before we actually get to that point, I want to do just a plain old inequality question, because some of the things I'm going to be showing you as far as word problems and inequalities are concerned are going to rear its head in this problem. And by and large, the stuff we're going to be doing with inequalities and word problems is going to be based on data sufficiency questions. In fact, virtually all the questions I'm going to do with everyone today is going to be data sufficiency. So I'm going to give everyone a few minutes, and then we're going to talk about the solution, and then we'll kind of bring in the word problems with inequalities as well. Okay, so that was about 2 minutes. Now, this is definitely a challenging question, and one that you're going to want to use very specific principles in how to deal with. So, a lot of times we look at questions like this, and especially because we're dealing with inequalities, and we immediately think about just plugging in values. And I do agree that there's a time and place for plugging, and I've talked about it in past webinars, especially when we did the inequalities webinar. But there's also the idea of being really strategic, because remember, when we have two equations, we're very in tune to doing a lot of substitution, getting everything in terms of one variable and solving. And then what happens is when we're dealing with simply an inequality, we don't do that anymore, an inequality with an equation. So the good news about this question is right off the bat, you know that your first statement is insufficient because it's telling you nothing about x. And you know that your second statement is inefficient because we have no idea what x and y actually is. However, what we do have the ability to do in this problem is we do have the ability to substitute in our values for, we have the ability to get x in terms of the inequality. Notice right now, the only thing we really know is that y is greater than 0. So for instance, we could isolate y here, and we could do that by bringing everything from the left to the right. So we have 5y equals 20 minus 2x. And then we can divide everything by 5 and say y equals 20 minus 2x over 5. Now, what's important about that is we can next take this and we can sub it in for y. And when we do that, we get 20 minus 2x over 5 is greater than 0. We can start by multiplying the 5 over, and we get 20 minus 2x still greater than 0. We can add the 2x over, and this gives us 20 is greater than 2x. Finally, we can divide by 2, and we get x is, divide this, x is less than 10. So to answer the question, is x negative, we still don't know. But remember, this problem, so the answer is E. But the problem could be easily changed to say something like, is x greater than 10? And if the problem said, is x greater than 10, then we would have an answer. The answer would be no, it's not. It's definitely less than 10, and the answer would be C. So what I'm hoping everyone is doing here is seeing that when you have an inequality within an equation, it's always going to be in your best interest to substitute from the equation into the inequality, especially if the question itself is in the form of an inequality. So what I want to do is I want to do a bunch more of these questions, but I want to now relate them to word problems, because one thing that the GMAT definitely likes to do is they like to test you in these types of problems, you know, in a word problem standpoint. So it's not just something you see in inequalities, it's something that can also be tested in word problems. And I think when that added element or added layer is put on top of this, sometimes we forget these rules and we go back to doing things like plugging and things like that. So we're going to do kind of a series of questions that are showing just what we did here, but we're going to add the word problem component to it. So we can start with this question here, give everyone about 2 minutes, and then we will talk about the results from there. Okay, so that was about 2 minutes. And like I said, I really do like this question because this is a data sufficiency question where if you front load your efforts at the way beginning and you get the question to read how you'd like it to read, you literally will walk into the right answer, which is great. And any time you can do that in a data sufficiency question, you want to do it. I'm not saying it always happens, but when it does, it really does fit like a glove, and it's going to really boost your confidence if you can do this on a test because you're going to feel like you have it made when you do these things correctly. So we're given that Carl has nickels and quarters, and then we're told that if he adds 12 quarters to his collection, so Q plus 12, he would have 3 times as many quarters as nickels. So that's going to equal 3n. The question is saying, does he currently have more quarters than nickels? So really the question is Q greater than n? Now Q stands for the current number of quarters, n stands for the current number of nickels. Now, if we're being strategic here, we can kind of look ahead at our statements and we can say, well, what do our statements tell us about? Well, they tell us about nickels and nickels. They don't really mention quarters. So the best thing we could do is make a question that revolves around nickels. And how do we do that? Well, all we need to do is get Q in terms of n. So by doing that, and we'll do it down here, we get Q equals 3n minus 12. We sub this in for Q, and the question becomes, is 3n minus 12 greater than n? We can bring the n over here, we can bring the 12 over here, and the question becomes, is 2n greater than 12, or is n greater than 6? Now, this is amazing because if we go to statement 1, the statement says n is greater than 6. So to answer the question, is n greater than 6, and to see that n is actually greater than 6, means that statement 1 is 100% sufficient. And then we move to statement 2. Carl has fewer than 8 nickels. We see right away that fewer than 8 nickels is not definitively answering the question whether the number of nickels is greater than 6. So the answer is A. So I want everyone, anytime they're in a situation where they have that equation, they have an inequality, even if the inequality is in the form of a question, just get in the habit of really thinking about substituting from that equation. And I promise you, you're going to have a lot of success doing that because the GMAT definitely likes to intermix equations with inequalities. So I want to do a few more questions like this, and then I will give things over to Scott. But hopefully, so far, everyone is able to kind of see and follow the patterns that we're seeing in these types of questions. So we're going to do 2 questions that are actually pretty similar to each other. And we'll do this one first. So about 2 minutes, and then we will talk about this one. Okay, so that was about 2 minutes. This question here is kind of an inequality question where we're dealing with rates. And these rates are dealing with things like dollars and hours, which we have wages for. So the first thing we can do here is, or the first thing we're given is that Bob makes D1 and works for H1 hours. So, and we're given that Joe makes D2 and works for H2 hours. Now, we need to know who made more money last week. So really, we need to set up this question and translate it appropriately to say, is D1 times H1 greater than D2 times H2? So with that said, we can go right through our statements, and you're going to notice our statements have equations. So we have D1 equals 10 plus D2 in statement 1, and that's just the translation of D1 is 10 more than D2. Now, we could plug this in right away and recognize that we're still going to have way too many variables to figure this out, or saving some time and energy, we could kind of say, you know what, that's just not going to be enough information, and really do the same thing in statement 2 and save our energy for the end when we can kind of plug these in all at once. So we have H2, of course, is 10 plus H1. So that means that statement 1 and statement 2 on their own are insufficient here. And what we'll do when we look at these together is, again, we're doing our substitution that we talked about earlier. So we have 10 plus D2 goes in for D1. 10 plus H1 is going to go in for H2. And then we're going to kind of do some math here. Once we sub these in, see we have an H1. We have D2 times 10 plus H1. And then we can distribute, and we can distribute on both sides. Remember, this is still a question. I mean, there still is an is there. And we get is 10H1 plus D2 times H1 greater than 10D2 plus D2 H1. Now, right away, we should see that the D2 H1s, if you subtract one or both sides, they cancel. And then additionally, if we divide everything by 10, the 10s go away. But we're still left with is H1 greater than D2? And the reality is we have no idea. Now, that's why the answer is E. I really like this question because rather than me plugging things for D2 and D1 and H2 and H1, the best thing to do is just to simplify this out till you get it down to the most simplified version of the question, and you're going to know whether or not that's sufficient. In this case, the question being, is H1 greater than D2? Well, we don't know the answer to that because we don't have any values for those. So what I want to do is one kind of counterpart to this question to show you another look, that you could see, and I think you're going to see that things work out a little bit differently here. So we'll do this one last question, and then I'll turn things over to Scott. Okay, so it was about 2 minutes. So hopefully everyone noticed that the setup here is pretty much the same as the previous setup. You know, is D1 times H1 greater than D2 times H2? And hopefully everyone noticed that there's a major difference between these two statements, meaning statement 1 and statement 2, than these two statements. And the difference I'm seeing is you see more than that relates to addition and more than that relates to addition. Here, when we translate our two statements, and once again, we'll make the decision that statement 1 on its own is not going to work, and same with statement 2, so we can more quickly analyze these together. But you see that we're dealing with multiplication as opposed to addition, and that's going to make a major difference when we sub these back into our question. Statement 1, D1 is 2 times D2, so D1 equals 2D2. H1 is 1/4 H2. Strategically, I'm going to multiply everything by 4, so I have 4H1 equals H2. The last step, just like in the last question, we're going to sub, so we sub there. And then we are going to take 4H1 and put it in for H2. And the new looking question is 2D2 times H1 greater than D2 times 4H1. Now keep in mind, because we're dealing with dollars and hours, H1, D2, none of those can be negative values because you can't have negative hours or negative dollar amounts as far as making money. So what you should notice is right away, if we want to, we can divide the whole thing by D2, canceling these, and we can divide the whole thing by H1, canceling those, and the new question becomes, is 2 greater than 4? And of course the answer is no, and that is sufficient to answer the question. So the answer here, B, C. So with that said, this was a really great representation of a lot of things that you could see in word problems, how inequalities are mixed with them. So in the future, if any of these pop up, try to utilize some of these methods, and I think you're going to find that you are very successful with them. So I'm going to turn everything over to Scott. So Scott, here's the ball.
Hey, thanks, Jeff. How's the audio?
Perfect.
Okay, great. Hey, everybody, good morning. Thanks so much for coming. And Jeff, thanks a lot. Jeff gave you a lot of high-value insight right there into some pretty, he didn't tell you they were difficult, but those were some pretty difficult problems. And he made them look easy, which is good because if you follow the right protocol, you know, as hopefully most of you are seeing, almost all GMAT problems can be reduced down into some simple solution. And if you haven't been here before, that's the motto of the day. If you've been here before, you know that's the motto of the day, is that we're always looking for simplicity. We're never looking to make things more complex, and I've said it before, I'll keep saying it because it's the one unifying theme that's going to immediately help you to do better and be faster at solving these things, because you want to make things more simple. So what we're going to do is we're going to do actually a number of sort of varied word problems in the second half of the webinar. And these are all particularly high value. So what we're going to do is we're going to shoot for a little over 2 minutes for each one, and then we're going to talk about them. Let's set our clocks and start on this guy now. All right, guys, let's take a look at this. This one's a little tricky, but the underlying solution is really easy. So we have this investment portfolio, and it grew by the same amount each year. Now, that's a really important piece of information. It grew by the same amount each year because that alerts us to the fact we're dealing with what would really be like an arithmetic sequence, right? Where we're adding the same amount in each period. So that's important. So it says the value of the portfolio after year 8 was 5/4 of the value after year 5, right? And we're told that we began with $100, and we want to know what's the constant amount by which the portfolio grew. So what we're looking for is this value of x that we'll set, and we'll say that x, very simply, is the constant amount by which this portfolio grew each year. And now it's pretty simple, guys. We're just going to set up a little table. We're going to say we have an initial value, right? And we're told the initial value is the $100. So we start with $100. And here's what I want you to pay careful attention to. What we're going to have next is value after year 1. Well, if we said that x is this constant amount that gets added to the value of the portfolio each year, well, after 1 year, our $100 will turn into $100 plus x dollars. And then the value after year 2, well, it'll be $100 plus x, or plus 2x. And then the value after year 3 will be 100 plus 3x. After year 4, we're going to have 100 plus 4x. After year 5, 100 plus 5x. After year 6, 100 plus 6x. And on the test, as soon as you saw the pattern, you obviously wouldn't have to just keep writing this out. Doing it for your learning, so you see exactly what's happening. But pretty quickly, we could see year 8 will be the initial $100 plus the x dollars, plus the 8x dollars rather. Okay, and again, just to be clear, how did that happen? Well, we said the constant amount that we add each period is x, and we've gone through these 8 periods. So at the end, we have our initial $100 plus 8x. Well, now we need to create a word problem, right? And we're told that the value of the portfolio after year 8 was 5/4 of the value after year 5. Well, that's easy because we have 8 and we have 5, right? So what we can say here is we can say that the value after year 8, 100 plus 8x, is 5/4 the value at the end of year 5. Okay, so this is the key equation. I think getting to this part is the hard part, but once we're here, it's just some basic algebra. So again, how did we get here? We were told the value at the end of year 8 was 5/4 the value at the end of year 5. Okay, so what we're going to do is we don't like that 4 down below. We're going to multiply the entire equation by 4 to get 400 plus 32x is equal to 500 plus 25x. And that's going to give us, move the terms around, that's going to give us 7x is equal to 100. That's going to be 100 over 7. And it says closest to, which is always a key rhetorical cue or a key word for estimation, and 100 divided by 7, well, it's about equal to $14 or so, right? So what that tells us is that the amount by which the portfolio grew each year is equal to about $14. Now, that's a reasonably tough problem. There's a lot going on, but I want you to see that at the end of the day, it's really simple. So when we're talking about growth problems, be on the lookout for the term, the word same amounts, right? So whenever we have the same amount each term, we can just add that same amount to each term. Okay, I'll let you guys take a minute to take down any notes on that. And we're going to do another problem. Okay, let's give this guy a whirl. So same thing, let's shoot for a little bit over 2 minutes, and we'll be right back to talk about it. Okay, guys, let's take a look at this one. So what do we have going on here? So we have a certain school trip, and the school allocated X dollars for lunch money for D students. But that morning, some of them overslept. So C of them overslept and missed the bus. So what happens is the lunch money was allocated among the remaining students. We want to know how many more dollars did the students who attended the trip actually receive than they would have received had all the students attended the trip. Well, the key is just to take it step by step and make it really simple, right? So if you think about it, what we have is we have X dollars that were allotted for D students, right? Well, how much did each student get? Well, they got X over D, right? So they got X over D. If there were X dollars available to D students, well then each student received X over D dollars. Now, C of the people didn't show up. Well, then the students who actually attended the trip, what did they receive? Think carefully here. Well, there's still X dollars, but now there's not D students, there are D minus C students. All right, let me say that again. Initially, we had X dollars for D students. Well, now we still have X dollars. However, we have a different denominator, right? We have a lower number of students who actually attended. Okay, so this is the dollars per student when everybody goes. This is the dollars per student when the smaller number goes. And we want to know how many more dollars did the students who actually attended get? So what we're looking for here, guys, is simply the difference between these two. So we'll say, okay, well, we'll say this is the number of dollars that the students who attended actually received. And we want to know what is that if we subtract the amount per student that theoretically the student should have got. So now it's just a place to do some careful algebra. So obviously we can't subtract these guys because of the unlike denominators. So a really fast approach to getting like denominators is we'll multiply up, and we'll multiply the denominators. So we get xd over d times d minus c minus x times d minus c divided by d times d minus c. So again, guys, all I did there, sometimes students have a hard time seeing that. So let me show you in red what I did. If you have a over b minus c over d, to get a common denominator, you can cross multiply and then multiply the denominators. So this would be a times d over b times d minus b times c divided by b times d. And if you notice, we have the same denominators now. So that's all I did over here in black. It's just a little bit harder to see because the structure in black is a little bit more complex than the structure in red. Okay, so just catch up with that if you're kind of taking some notes. So what we can do here, guys, is since we have the same denominator, right? We have the same denominator. We can put the subtraction over the same denominator. So that will be xd, and I'll pass the x through here on the right side, minus xd minus, make sure I keep that, minus xc, and this is the same denominator, d times d minus c. Now, the key thing here, guys, is remember we're subtracting the whole second numerator, so I put it in parentheses here just to remind us of that fact. Because now when we do the subtraction, what we see is we have xd minus xd plus xc. And that plus there is one where a lot of students actually put a minus by accident. Okay, we don't want to do that, so plus. Okay, we still have our denominator, which is d times d minus c. And of course, we can see in the numerator that those two xd terms cross themselves out. And we're left with xc divided by d times d minus c. And that looks like that's about as far as we can simplify this thing. So we'll go up and we'll hope there's an answer there. Looks like that. And there is. So answer choice E. Answer choice E. Now, here's the deal. If you wanted to plug in numbers for this x, this d, this c, and it's up to you, but it's going to be a real headache, and you're not going to learn anything. And if you get some answer choices that work, you're going to have to test a new set of numbers, which is kind of maddening to me. But if you want, practice it both ways. But there's nothing hard about this algebra we just did. It's actually a lot easier than picking numbers because we're using variables, and we're less likely to make a mistake, at least in my opinion, when we're using variables. So this is a really common type of question. So make sure you really pay good attention to this, and make sure you study this guy. Okay, give you guys a minute to take down any notes on that guy you want, and we're going to do another question. All right, let's give this guy a whirl. This is another one that, in general, students have some difficulty with, but we're going to make it really simple. So let's shoot for a little over 2 minutes starting now. Okay, guys, let's give this one a whirl. So what we have here is we have, it says if the digits of a two-digit positive integer reversed, the new integer would be 81 less than the original integer. Which of the following could be the value of the tens digit of the original integer minus the units digit of the original integer? So here's the thing to think about. Doesn't matter what we use, but let's say U is the units digit of the original integer. And let's say that T is the tens digit of the original integer. Okay, so here's where the logic comes in. Well, what can we write? Well, a lot of students say, well, the number is T plus U or something like that. But it's not T plus U. It's actually 10T plus U. Because if this is the tens digit, the tens digit by definition is always 10 times the unit digit, right? Regardless of the values of T and U, right? So whatever T and U are, it doesn't matter. The tens digit is always going to be 10 times the units digit. And that's a really important relationship to see there. Okay, so now if the digits were reversed, so pay close attention, if the units were reversed, now we'd have 10U plus T, right? Where this is the tens digit and this is the unit digit, but remember the digits were reversed. The key thing is we can't forget about this 10, right? Because the tens digit is 10 times the units digit. All right, here's the original, here's the reversed, okay, algebraic structures. So now we can write a word problem, we can write an equation, because it says the new integer is 81 less than the original. Well, the new integer is going to be, well, let's actually reverse that. Let's put the old one first. So we'd have 10T plus U, so the original, and if we subtract the reversed, from the original, we know we're going to get 81, right? And if you're wondering where the green came from, it says the new integer would be 81 less than the original. Okay, so if we take this guy and subtract this guy, we have to get 81. And there's a number of ways we could write this equation, but this is by far the most logical and the most streamlined way to write this equation because it's a direct translation from the stem. Okay, what we can do here then is just collect some of these like terms, put them together. We see we have 9T plus 9U is equal to 81. Of course, we'll factor out the 9 or divide by the 9, any way you want to look at it. And we see that we have, actually that should be, this guy here should be a minus, shouldn't it? That's a minus. So factoring out the 9, we see we have T minus U is equal to 9. And that should be pretty helpful because it says which of the following could be the value of the tens digit minus the units digit of the original number. And lo and behold, we define this to be the tens digit of the original. We define this to be the units digit of the original. And therefore, the subtraction of the two would give us 9, which is answer choice C. So the key thing here, guys, is to realize that in almost all word problems, there's a logical leap you have to make on your own. And once you make that logical leap, you're in pretty good shape. And in my opinion, the important logical leap to make here was the fact that the tens digit was always 10 more than the units digit. And once we saw that, as long as we were careful, the right answer was pretty easy to get. If we didn't see that the tens digit was 10 times the unit digit, it would have become a problem. Okay, guys. Well, I hope you found some value in the material we covered today. We'll be here same time, same place next week. As I always say, if you're not using the right materials, you're not going to get the results you want. And then what's the point of putting in your hard-earned study time and effort? So if you're not using our materials and you want 3,000 more problems like the ones you saw today, sign up, check out a trial. Our students are literally crushing the test, and you know, we love nothing more than to help you as well. So with that said, I hope you all have a great day. If you need any help, please reach out to us. And best of luck with your studies, everybody. Enjoy.